In this video, we're going to write a definite integral to represent the volume of the solid that's formed by the region bounded by these two curves and the as we revolve about the x-axis. I'm a huge fan of Desmos graphing calculator, and I will link it below. That way you can use it as well. It's a free online graphing calculator. Excuse me, but I have taken a moment to graph these two functions in Desmos. And so I want to share that with you. Looks something like this. And I'm just going to draw the region we're talking about here. So there's your x cubed, and here's our x squared. We have these intersection points at 0, 0 and at 1, 1. Okay, now we're revolving about the x-axis, so we are going to be using washer method. So that has a pi in front. Our bounds are from 0 to 1, and we're doing the integral in terms of x's. So here's my axis of rotation. The first thing I'm going to have my big radius that goes from the axis of rotation to the furthest curve. In that case, this is the x squared. So my big radius is x squared, and of course I need to square it. Minus, then I'll take my small radius, which is from the axis of rotation to the closest curve. In this case, that's x cubed, and I need to square that. And then, of course, we want to do dx here. Now, if you're still in Desmos, let Desmos do all of the hard work for you. If you will type int, and I'll do 0 to 1 for my bounds. And then notice we are doing f of x and squaring it first, minus, and then g of x, lots of parentheses here needed, notice. Now, you'll notice that I did not put the pi in my integral, and here's why. Because I want Desmos to give me the decimal, which I'm going to turn into a fraction, so that I can give my answer as 2/35 pi. If you put the pi in Desmos, then it won't return a fraction for you at all. So I leave the pi off when I put my integral in Desmos, get my answer in a fraction, and then I can put the pi on my answer.